would like to share some of my recent interests in the link of the microbiome and the genetic disease. I will focus on Parkinson disease. But what is of concern, in particular in China, is that the projections of evolution of Parkinson disease increases much faster in China, in Asia, than elsewhere. So what is Parkinson disease? Neurological disease caused by a lack of dopamine within the brain. The destruction of neurons is due to accumulation of aggregated signal plates, which form so-called Levi's bodies, and they lead to destruction of substantia nigra in the brain. There is a hypothesis that disease maybe starts in the gut, and then this signal plane aggregates kind of propagate via vagus nerve to brain. The phenotypes of the Parkinson disease, there are two types. The non-motor symptoms like psychiatric, autonomic, sleep, anosmia, loss of smell, cognitive problems, constipation, and these symptoms often predate what is most debilitating, which are motor symptoms. Parkinson's disease has a genetic component. Mutants in the GBA1 gene, which encodes glucose pyramidase, these people have a high chance of developing Parkinson's disease. Mutations are found in about 15% of patients, and the increase in risk if you carry a mutation is quite high. However, not everybody who has mutation develops disease. At only 10 and 30% of people who have that mutation develop overt disease by the age of 80. Why some people do and some people don't? It's a question which is often asked for low penetrance clinics. Presently, clinicians don't really have a way of finding out who will and who will not develop the disease. On the other hand, analysis of Parkinson's disease patients has shown a clear dysbiosis change of the microbiome in the patients. There are some beta transplantation experiments in mice show that you can induce Parkinson-like symptoms at the stool from patients. I'll address the hypothesis that the gut microbiota composition of people at genetic risk, which carry mutation GBA1 gene, will contribute to the overt disease, and we can try to help identify people who will develop the disease by gut microbiome analysis. And the approach is to collect clinical, dietary, and microbiome profiles to find out whether we can say something about the disease. I'll try to tell you what's going on in people who are not at genetic risk to develop Parkinson's disease, but who can get Parkinson's disease nevertheless. Large fraction of the gut microbiome changes gradually from healthy individuals across both risk to Parkinson's disease patients. In patients, this fraction is associated positively with severity of the disease and negatively. Thus, in individuals genetically, it is associated with the progression of disease. Individual microbiome species that compose this fraction correlate with variables relevant for disease. PD-enriched species correlate positively with severity variables, negatively with health variables, converges to PD-repeated species, and individual microbiome species can be used to compute Parkinson's disease microbiome flow that's structured by healthy individuals into groups with clinical variables goals. Those are the adaptations. Microbiome analysis can stratify healthy individuals with clinical variables. Those are the basic of with the patients possibly try with this to develop meetings, orienting them toward more clinical examination, which is cost and long, right? Second, colorectal cancer screening. The screen because it's cheap at fast, and risk mitigation. Healthy eating seems to modulate evolution of the microbiome in patients, and I haven't had time to stress it in healthy individuals, but it's exactly the same. Constipation is prodromal syndrome can be combated. And with this approach work for other neurological and chronic disease. I'm really looking forward to seeing what Moscow will give, what MMHP will give, what French dumping will give. You know, future will be exciting.